Hi, welcome to Code.io, and in this episode of Leetcode problem solving series, we are going to solve a question called 2 sum 2. It's actually 2 sum 2. There is a 2 sum 1 or just plain old 2 sum which we have already solved. You can go and check that out, and in this video we are going to solve 2 sum 2. And if you think this question name is funny, wait for the next question. It would be even more funnier. Okay, now here's the question, and it's the 167th question, and it's a medium question, but don't get jittered. Like, it says medium, but it's a fairly easy question. So 2 sum 2, and they have given that the input array itself is sorted. So let me just go over the question statement first. Given a one indexed array of integers numbers that is already sorted in a non-decreasing order. Okay, so meaning that you have given a sorted array in ascending order, like it starts from a lower number and ends at a higher number. That is what, like, they have just complicated it a bit by saying non-decreasing order, but yeah. So find two numbers such that they add up to a specific target. So just like in 2 sum, you are going to find a couple of numbers that add up to a target. Okay, but the difference is that we are given a sorted array in this case. Let these two numbers be numbers of index 1 and numbers of index 2, where 1 is less than or equal to index 1 and less than or equal to index 2, which is less than numbers.length. Okay, so that just basically means that you are supposed to return two numbers in that, like those two numbers are supposed to be indices, right? You are supposed to return them as a list. Okay, so that is it. Now we have a couple of examples here. We can look at that and then we try to solve the question. Now if you look at this, we have this array 2, 7, 11 and 15. These are the numbers of the array, and the target that are given is 9. Okay, so how exactly are we going to do that? A brute force approach would be using a couple of for loops, using nested for loops. Okay, what would you do in that case? You take one of these elements, let us say 2, which is your I, and like I loop, the outer loop, and you take another number j and you iterate through this. You find array of I plus j, plus array of j. You try to find this. So it would be, you'd go through this thing. So it would be 2 plus 7 and 2 plus 11 and 2 plus 15. Now this is 9, this is 13, and this would be 17. Now in this case, this is our answer. So you would be returning its indices, which is 0 and 1, but here they have given that it is what, one index array, meaning that you are supposed to return 1 comma 2. Okay, now in this case it's easily found here, but what you usually do is you take this value of I here is as initial value and you iterate this j through the entirety of this list, and again you update the value of I to the next element and you again iterate through the entirety of the list. In this case you would be having two nested loops. Okay, one is the outer for loop and for I, and inside that you will have another for loop which is for j. Now if we use two of these loops, the time complexity that you would end up with is order of n squared, but we here are required to solve it in order of n. Okay, I'm not sure if they have mentioned it here anywhere, but they have given a very important what do you say, observation or condition that would be helpful for us, and that is they have given that this array is a sorted array. Okay, now what advantage does that give you? Now the approach that we are going to use to solve this problem is called two-pointer approach. Okay, so what I'm going to do is I'm going to take a couple of pointers. Pointers doesn't really mean the actual pointer variables that store the address. This is just a variable that denotes indices of a array. Okay, now the first pointer that I'm going to take is I pointer that points at the first element initially. Okay, the second pointer that I am going to take is a j pointer that points at the last element. Okay, now what I am going to do is I am going to find the sum of these two elements. So this would be array of I plus array of j, right? Now in this case, this is 2 plus 15, which is equal to 17. Now the target that we are supposed to find is 9, but we have got 17. 17 is greater than 9, right? I hope we are clear with this. 17 is greater than 9, meaning the required sum that we want is, it should be lesser than what we currently have. So what we can do is we can move our right pointer one step before or one step forward, or in the case of j it would be backward. So what I am trying to say is we are trying to decrease the higher end or the upper bound of our considered pointers. Okay, j is always pointing at the larger numbers, right? J is coming from right, so it's pointing at the larger numbers because this is a sorted array. Now since our sum here is greater than, or the target is lesser than our current sum, we are supposed to reduce our elements, right? We are supposed to reduce either array of I or array of j to arrive at the required sum, to arrive at the target. Now here you cannot reduce the variable I, you cannot reduce the number pointed by I, because 2 is the least value, 2 is the smallest value in this array, so you cannot reduce that. Only thing that you can reduce is j. Okay, and also you know that j is the higher value, right? Out of 2 and 15, 15 is the higher value, so it makes sense for you to reduce that. So now you have done j minus minus, or j is reduced by 1. In that case you are going to again compute the sum here. So it's 2 plus 11, that gives you 13. 13 again is greater than our target, right? So what I am going to do, I am again going to move j to the left. So j has been moved to left because our sum that we currently get is larger, is greater than our target, so we have to reduce the numbers that we are adding. So we are moving j to the left so that the upper bound gets reduced. So now we have 2 plus 7. So 2 plus 7 gives you 9, and 9 is our required target, right? 9 is our target. So in that case you are just going to return the index of these numbers. This is 0, 1, 2, 3, 4. Sorry, this is our target, so never mind. Okay, now this is the actual index that we have, but in the question that they have given, it's a one indexed array, right? So even if you have found that 0 and 1 is our required pair that adds up to this, you are going to return 1 comma 2 because we are assuming it as a one indexed array. Okay, now I hope this makes sense. It's not a complicated concept. You're just having a couple of pointers at each end. You're computing the sum. If your sum currently is greater than our target, you're going to decrease the j value. If in case it's lesser than your target, you're going to increase the I value. Now in this case, we have not seen that, right? Yeah, we have not seen that. Okay, but yeah, it's quite simple. If the sum of numbers at ith position and jth position, if the sum is in fact lesser than the target, you are supposed to increase one of the values, right? So in that case you would be moving your I to the right. Okay, so that is all. I hope you understood this. It's quite easy. Now we'll go to Leetcode and try to code this, and we'll try to look at the edge cases as well. It's fairly a simple question, but yeah. Now here we have this toSum method, and as arguments we are receiving a list that is numbers and a target that is int. Okay, now what I'm going to do is I'm going to create these pointer variables I and j. So I is equal to 0 and j is equal to len of numbers minus 1, because we are thinking about indices, right? So It should point at the last index of the array or the list. So it should be len of the list minus 1. So that would make it point at the last element. Okay, now to iterate through all the numbers here, the condition that I'm going to give is I less than j. Why I less than j? I is the variable that we use to point at the left edge, right? The left edge or the smaller number of the pair, and j points at the larger number of the pair. And since it's a sorted array, there is no way where I and j can go over each other. In that case, it would be like j holds the smaller element and I holds the larger element. That simply is not possible here, right? Because in that case, you would have compared all the numbers and you're going to do that again with different variables assigned to it, but that just doesn't make sense. So the condition that we are going to give is I less than j. Okay, so while I less than j, you're going to compute the sum. Sum is equal to numbers of I plus numbers of j. Okay, we are computing the sum. Now we are going to see if the sum is equal to our target value. If sum is equal to target, it means that we have found the right pair. Sum is equal to target, we have found the right pair. So you can just straight away return that, return of I plus 1 comma j plus 1, because they are asking the indices based on one based index or the positions that these numbers are in. Although we are computing it with 0 based indexing, we are returning it as one based index or the positions of these numbers in the array. Okay, so if sum is equal to target, you are returning these. If sum is not equal to target, okay, in that case you can use else if but I'm just going to use if, because if the first condition had occurred, it's just going to return and that is end, right? So you can use if as well. Also you can use elif, it's not an issue. If sum is lesser than target, okay, if sum is lesser than your target, it means that you're supposed to increase your numbers that you're adding, right? If you increase the numbers that you're adding, your sum will increase. So you're moving your left pointer to one step right. Okay, you are moving your left pointer, you are increasing your left pointer by 1. So your left pointer is I, right? So I plus equal to 1, I is increased by 1. Else, in that case, its sum is not equal to target and sum is not less than target, it means that sum is greater than target, right? In that case, you would decrease j by 1. Okay, since sum is greater than target, you have to reduce the value of sum to arrive at target. To reduce the value of sum, what would you do? You would reduce you would leave our largest element and you pick another element. Okay, so you are decreasing j by 1. So j is decreased by 1. Now this should be fine, because you will definitely come up with something that you can return, but just in case to return something after the loop, outside the loop, I am just giving return an empty list. Okay, now I hope this is it. Let me just try and run this and see if this works. Okay, it's working for the sample test cases. Let me just submit it. Where is it? Okay, it has accepted our solution. It's quite simple, fairly easy. I hope you understood this. You just have a couple of pointers. Since this is a sorted array, if your computed sum is lesser than your target, you move your left pointer. If the sum computed is greater than your target, you move your right pointer to the left. So that is it. It's very simple. I hope you understood this. If you have any questions, please put them in the comments. I'll get back to you as soon as possible. And if you have question suggestions, put them in the comments as well. I'll try to solve that. See you in the next video. Bye for now.